most people have already heard it. Welcome to the new faces here. Cryptorado is like the local sort of a hub for blockchain stuff in Denver area. Meet every other Thursday, meetups going on, just to hang out, kind of happy hour thing at Seed Stock Brewing over on West Colfax. I think Crypto Mondays has ramped back up on alternate Mondays. So one Thursday is Seed Stock, the next Monday is Crypto Mondays, and they're finding a new home for that. Solidity deep dives on there. Basically, if you want to know what's going on with crypto stuff, it's a good place to start. Also a Discord channel, you can jump in, talk to people, hang out, ask for things, et cetera, et cetera. They are the people who brought us the Waterloo and the cold beer this time, and the pizza. And then Bullet Network is responsible for the space. Colin used to work there, so he gets to show Bullet Network.
Yeah, I used to work there. And my old boss wants to still sponsor this. I can kind of contribute to the project like here and there a little bit. But yeah, Bullet Network is like a on-chain accounting, invoice, payments, payroll platform. They were kind of the first folks to figure out, like, or maybe not figure out, but just we implemented for the first time, like, oh, like what happens if you NFT an invoice? You essentially own your credit. That's kind of cool. And been messing around with that idea. Hopefully the next month we'll actually go live with an integration with Huma Finance, which allows you to get like instant access to liquidity based on like certain like parameters. So if you're a pretty good creditor, you could factor your on-chain invoices against like a DeFi liquidity pool that we would sponsor, or yeah, we might look at doing some partnerships with some bigger Web3 companies that are handling like payroll that could kind of onboard payroll factoring. But yeah, that's what Bullet Network's up to. It also just tries to be a hub for all your transactions. So we're about to launch a transaction journal feature, which helps, which pulls in from all the Etherscan chains that we support all your transaction data, and you can sort of like journal it and then save it in Bullet, and then see kind of your P&L over the year, export it. Like if you've ever made random ERC20 transactions and have wanted to document what they were for, you could use the tool to do that as well. So it's like kind of like a personal finance suite is what it's moving into, but does a lot of different things.
Nice. Yeah, I just did my crypto taxes, so and the more tools that help out with that, definitely the better.
Oh, dude, yeah, like
Such a
last
nightmare.
February, it's like I don't know why I sent $30 to this address that I've never, like, what was I doing?
Yeah, I may or may not have looked at a bunch of GMX transactions and had no idea what was going on, and so I may or may not have tried to figure out the $30 that I chucked into there to get a token drop.
Yeah, right.
Might not show up on somebody's accounting that it should.
Oops. Well,
probably it did, but maybe it didn't.
Probably did, maybe it did. Plausible deniability. Yeah, this isn't recorded, right?
Yeah. Cool. Awesome. Well, with that, if you couldn't tell, Colin's the mad genius behind all the actual knowledge transfer stuff here. It's pretty casual. I'll let him kind of intro the topic and get us started on that, but questions, comments, side remarks are welcome pretty much throughout the whole thing. I think, I feel like we're lights off people. I'm going to shut the lights off so it just feels a little more,
We are lights off
more
people.
intimate, and we can see the screen a little better.
Yep. True.
Cool.
True. Yeah, I've got a link for the repo in the meetup, and yeah. So today we are gonna have a little chat about account abstraction. Who here has heard about account abstraction? Okay, 2, 3.
Is this the new 4337 thing?
Yep, new 4337. Yeah, here we are. Oh wait, this is the audit report. Here we are. So this is the EIP for account abstraction. Also, could someone please sanity check the stream for me real quick to make sure that I'm streaming? I didn't do that a few times ago, and now I'm forever scarred.
I don't think you've sent the other links though.
Ah.
Like a repo.
Okay. Cool.
Stream is good.
Stream is good. Very good. Here, let me just throw that link in there. Here we are. I'm gonna toss, stream link, and then here's the link to just a forked repo, and then I'll also throw this as a comment in here. Perfect. Okay. Sweet. So, so most of us are unfamiliar with Account Abstraction 4337. So there's this issue of, this is like a pretty big change to Ethereum and how wallets will work. I remember having the experience when I first started consulting that like, wow, this whole dApp thing is crap. Like literally you have to ask someone to download an extension and like set it up for 20 minutes before they can even use your app for the first time. It's ridiculous. So there's been a lot of discussion ever since like EIP 80-something about like how you can have programmable accounts. So the thing with how Ethereum works is the reason why you have an account and the reason why you have a wallet here is you have a private key and a public key. And that private key comes from that like very secret seed phrase that you have when you set up your wallet or your hardware wallet. And that seed phrase will end up just being like a very, very, very big number. That very big number represents a point on an elliptic curve. And it's just, if you're interested in this, like look into encryption. Web3 is what got me into cryptography and encryption, and it's the basis for the word cryptocurrency, right? Is that your private key no one knows, but you can derive a public key from that, and your private key will sign a piece of data, and then anyone can verify that private key signed or authorized that piece of data without revealing what the private key actually is. So that's just kind of due to the nature of elliptic curve and elliptic curve math, is that you can prove that someone kind of holds a private key without the person having to actually reveal what that private key is. It's how we have encryption. It's how we have things like TLS. It's how we have things like SSL. It's what happens when you see this little lock icon on your browser, right? It's kind of the basis for encryption is that like, everything is sort of private key based, and it's a way to manage these secrets, right? So when you're signing a transaction, you're saying, I authorize you to deduct Ether from my account and put this transaction on the blockchain on my behalf. So that's what's happening, right? So when you sign a transaction on Ethereum, you get a blob of data to your wallet. Your wallet takes all that data and then signs it with your private key and then passes it out. The node will verify that your private key, that the address that signed that piece of data relates to your Ethereum address. That's your public key. And then it'll post it on chain. So that's kind of how the normal wallet setup works. Is wallets can do one thing, is they can just sign transactions. They can technically sign any piece of arbitrary data. We've put a lot of guardrails around wallets to make sure what they can and can't sign. So you can sign messages, you can sign transactions, but the point is that private keys sign transactions, and those transactions go on the blockchain. This would be changing the structure, or not changing, but adding a new way for you to put transactions on the blockchain via, instead of transactions, what's called a user operation. So normally when you sign your transaction, you put that transaction into a mempool. And it's just where kind of all these transactions float around, until they get picked up by a miner who's willing to mine the transaction based on your parameters. So this suggests a way for you to have an alternate mempool. And so instead of having the mempool, let's see, I believe there's a little more. No, I guess that was the only. Yeah, so I guess instead of your transactions going into a mempool to get picked up by a miner, your user operations could go into an alternate mempool to get picked up by a bundler, who will then take a bunch of transactions and then submit those bundled transactions on chain. So it's like an alternate decentralized mempool for someone else to essentially like relay your transactions on your behalf. So this seems really simple at first, but it allows for things like smart contract accounts. It allows for you to basically create wallets on behalf of your user. It would allow you to deploy like, if your user gives you an email address, you could sponsor the gas and have it deploy a Gnosis safe with, some sort of private key that will like end up being a signer on that safe that they still own, right? So it abstracts this concept of it allows you to start to abstract this concept of wallets and gas from transactions. So hopefully in the next like year and a half, when wallets really adopt this standard and push it forward, we'll start to see a world where like you can authenticate with Twitter or with Google, and you can get kind of like a semi decentralized wallet to get started in blockchain, right? Like, I think the coolest part about crypto is that like you can kind of do all this crazy self-custody, but self-custody is massive overhead and it's really difficult to get right. Like it's all the horror stories that we've heard about with wallets and losing funds and all my apes are gone, right? Like all the memes. It's the UX is horrible, but this will probably give us like a progressive decentralization path towards allowing people to use a blockchain that is kind of has self-custody as a first-class citizen, but also has this alternate route to get people onboarded, right? Maybe you could have a wallet that's completely authenticated based on a session key, right? Like a normal JSON web token, or right that says like I allow this website to make as many transactions for me in the next hour as long as I'm logged into this website, right? So kind of the possibilities become a little bit endless. And so this is, I think, going to be the decided upon way to handle transactions. And yeah, so my thought for tonight is that we would go through the repo, because actually, besides the alternate mempool, which is a bunch of node stuff, like Ethereum node kind of client stuff, it's actually mostly Solidity contracts. So that's why I believe they chose this EIP in favor of other EIPs, is because there were actually no underlying protocol changes to Ethereum. Like there was another EIP that suggested that there would be a new opcode called authcall, which would allow contracts to do things on behalf of other contracts, which is not really possible now. So it's like consensus layer changes to Ethereum, where this doesn't have any consensus layer changes. It's a smart contract, and it is it's a couple different smart contracts. It's a standard for a smart contract wallet, and it's this kind of tertiary standard for what an alternate mempool would look like, and kind of for miners to become bundlers as well.
Do you know none of the other account abstraction EOTs are going to move forward, or is that still TBD, or like do the other approaches have like extra features that come at extra cost but still might end up coming through?
Yeah. I don't think, I don't know. Like the honest answer is I have no idea. It just seems like the temp check is that this is the one that we're kind of all moving forward with, because there's like not any consensus layer changes. So yeah, I think the short answer is I don't know. I also saw that on the off-call one, that other EIP that I don't remember the name of, there's just a lot of nefarious ways that transactions can be mixed together to be kind of dangerous. And it's really hard with a Turing complete language or a Turing complete blockchain, like Ethereum, to introduce completely new ways of authenticating transactions while also not bricking any or putting any current systems at risk, right? So ideally, since developing Solidity is dangerous as it is, ideally we wouldn't make it more dangerous by introducing more complex architecture. And so I think this is like a pretty solid way forward, because it just sort of abstracts out wallets instead of kind of throwing in a new way to authenticate calls into the blockchain. So any thoughts or questions or before we dive in? I feel like we could dive into the repo and then maybe even like screw around and try to make our own 4337 compatible wallet even. We have the time.
I'll just say that we're doing the Safe Hackathon this month.
Oh
We
yeah.
actually have a branch of the GeoWeb that does all this stuff. But
Mm.
Still
Sick.
in progress.
Nice.
I can show you eventually.
Yeah, that would be great. Honestly, I got back from a work trip just last night, so this is pretty thrown together. So we're gonna all have to kind of come together on this one because I haven't really looked through the spec a ton, but I like kind of understand the frame of it, and yeah, maybe we can just like seep into points of interest that people see in the code, kind of once we have like a mental model for it. How's that sound? Cool. Yeah, so let's look at the EIP real quick, because I think nailing the mental model first will be a good thought. So yeah. Let's talk about transactions real quick. So if you come to previous meetups here, you'll know that Ethereum transactions, like I said, kind of have this it's just a data blob, and so it's like, it kind of looks like this, right? Where you have a to field, which is so you have a to, yeah, so just to demonstrate here, you have a to field, which is like string, a from field, which is oh yeah, ETH address. So I guess this is like the layout of every transaction. Sorry, I'm trying to gather my thoughts here. So really you have two, you have value, which is like a number, that's the amount of ether you're sending. You have data, which is like kind of like a byte string of whatever you want. And then you have like a signature, which is the signature of the wallet that signed it. You have like a maximum amount of gas you're willing to pay. I kind of forget all the EIP 11 something, whatever the gas one, added some new things in here, which basically is like, max base fee for gas or something.
But basically, your wallet gets this like little transaction object, and then you'll sign it, and then it'll go to the mempool. And if the signature matches what was signed, then the blockchain is down to include that. So this, instead of a transaction type, we have like a user operation type now, and so that's gonna have a few different things. Oh yeah, also I forgot this does have a nonce, which is just the amount of transactions that your wallet has ever sent, to make sure that like no one can kind of take this transaction and like execute it multiple times. Because say for example, if this transaction had the nonce of 1, when you sign it with your private key, the signature that comes back will include you signing that unique nonce. And so if someone tries to use this transaction over and over again, but they change the nonce to 2, right? Like now the signature won't match the data that was signed. So nonces are necessary to prevent what's called a replay attack. So it looks like this is, instead users package up the action they want in their account and take it into an ABI encoded struct called a user operation, which has the sender field, which is like from, has the nonce, which is an anti-replay parameter, has a few different things like a NIT code. So this could be like an optional initialization code of an account. So like if it's this account's first transaction, you could say like part of it's a NIT code is like deploying a Gnosis safe, or paying 5 cool tokens to get a cool wallet, right? Like it could be completely arbitrary, right? The cool thing about Ethereum, like bytes and Ethereum, is that you can package up these calls to just be executed arbitrarily, and all a transaction is on Ethereum is just a string of bytes. So next you have, there's call data, call gas limit, verification gas limit, which we'll get into the verification step in a minute. So this is the actual data that's being sent in the transaction. It maps 1-to-1 to data. And then you have like a, oh, we might have a straggler. Nope, that's my landlord. I move out in a month.
Mute.
Yeah, he will be a straggler. So, and then there's some gas limits that we see around verification. We'll talk about that as well. And there's also this concept of paymaster. And then finally, we reach signature. So kind of all this to say is that like a user will signify what they're trying to do. If it's first time, they get to signify also like some initialization code, which will make this super flexible. It also specifies how much gas they're willing to pay for doing that. And then them actually, their signature of all this stuff, right? So user send user operation objects to a dedicated user operation mempool, which we talked about. We're a specialized class of actors called bundlers. So either, block builders, like miners, right? Kind of running special purpose code, or users that can relay transactions to the block builders through like a bundle marketplace. So like, it's kind of like a bid ask system where it's like, hey, I'm willing to pay this much gas or this much to include this transaction, do it for me. And then it will create and bundle transactions. A bundler will bundle multiple user operations into a single call, and then there is a handle ops call on a published global entry point contract. So I guess I wish I had maybe I could find like EIP4337 diagram, because this would be super helpful for us. Yes, perfect. Okay. All right, so here we go. So we have users, which users previously would just like submit and sign transactions. Now they're signing, or they're creating these user operations, and they send them to the user operation mempool, which is just an alternate mempool. These get picked up by the bundler. The bundler will take all these transactions and they'll submit them to what's called an entry point contract.
So we're now having three separate entities here. We have users, like we have users. We have this mempool, and then we have this entry point contract. So this is actually entering in. This is actually kind of on chain, right? Like we're entering into the on chain domain here. This is an Ethereum smart contract called entry point, which is going to exist at like a fixed address on every single chain, and it receives and parses and executes all these user operations. So the entry point to the entry point is going to be this handle ops function. So like the bundler will submit all these user transactions to the handle ops function, and then the entry point contract will validate all the user operations to make sure that they actually can be executed, and then it will execute them all together. So that's sort of this new architecture, is it actually sends it to a smart contract instead.
Do you know what the gas impact of having to go through the handle ops is?
Yeah, so there's going to be the gas impact is going to be quite a bit bigger than the normal. I don't know. It's so right. So like you have to do a lot of computation on chain to make sure that the transactions can be executed, and that you handle who executes them and who gets like a refund for doing the execution. But also, if you remember, the base price for an Ethereum, the base price for a Ethereum transaction is like 20K gas. So by bundling transactions, you kind of void that base fee of even submitting a transaction anyway. So it's going to be a little more expensive, but theoretically, if you bundle a bunch of transactions, it will be a little, like you kind of make some of it back up in a way. So just to show what this looks like, this is the entry point interface. So this is not actual code, but this is just the function signature. So it takes in an array of these user operations, and also like the beneficiary to receive any kind of fees. And then if we go to the actual entry point contract itself in the contracts repo, handle ops, so it executes a batch of user operations. So it gets the ops length, and then it, creates this new user ops info. And so it will, looks like we see two for loops here. It validates prepayment, and then also there's this concept of paymaster, which we haven't talked about yet. And then so it just has two steps, right? For all the ops, it validates them, and then it executes the operations, and then it will compensate the beneficiary. So it's kind of the basic structure. Is is everyone like following? Are we clear on that?
Mm-hmm.
Cool. Yeah. So kind of like we discussed, the entry point is a singleton contract that will exist at one fixed address, and it just contains the logic for validating and for refunding the sender or any address. And it's up to the bundler to choose which transactions are going to be economically viable for it, right? So you actually have to in the same way, like you can submit transactions to the Ethereum mempool and say that you're willing to pay 0 gas for them, and they'll sit in the mempool until they expire, right? Because you're not actually it's not a good bid-ask system. This will be just the exact same way. So it's really flexible here because it tries to create like an open market for like economically viable user operations that either I'm willing to front the cost on myself because like I want to onboard my users and I just got their email address and I want to spin up an account for them, or like you just kind of like send them to the sharks and allow users to create transactions that like maybe I want to pay my gas fees in USDC and I'm willing to pay an extra 30 cents bump to make that happen, right? And if a bundler finds that to be economically like interesting because of the current like gas environment, and you know USDC is great, so then they would just pick up that transaction and execute it.
So wait, is the bundler in here? What I'm trying to figure out is the bundler getting a reward for submitting, or is like, because you're describing like where the gas fee is, but normally I think
Right.
the gas fee is on chain.
Yeah, correct. Yeah, so it's arbitrary, right? The bundler in this case could be the bundler in this case, the person calling handle ops could be the beneficiary. That would probably make sense in an open market. The beneficiary could be a zero address, right? Like saying like there's like no beneficiary because there's like like I'm paying for this operation, and all my user operations actually don't give this person any refund, or like the beneficiary could be it could be any address, right? Like I could ask my friend to be a bundler and send them a transaction and they relay it on my behalf, right? So it's a completely flexible open market. It just builds the rail for people to say, hey, like there are these user operations which would kind of protect and give users flexibility because users want to do stuff on chain. And then here are the rails for how users might refund or create a market. Now go play. Go figure out how to make a market. Go figure out whatever you want to do, whether it's you do like a whether you drop your operation and your signature to your friend in an email and they call handle ops for you because you have gas, or you submit it to this alternate mempool, the user operation mempool. It's totally up to you.
And the beneficiary, you could be giving them ETH, or you could be giving them something else. Is that because you mentioned like paying your gas in USDC? Like how would that work?
Yeah, let's crack into that actually. So if I F12 and a compensate, great, no definition found. Here we go. So compensate with an amount. So I guess compensate can't be the zero address. So it looks like there's a beneficiary for every single handle ops transaction. And then it just, this jargon here is just Solidity speak for send this person Ether. And then it just requires that Ether Ether transfer was successful.
So it's not ERC20 written?
So what?
Or someone just use this as an interface to do?
So this is a way to handle like native tokens, but I think we would have to go one level deeper, right? So I think we would have to go to the execute user operation, because that might handle how payment is actually executed. Maybe part of the user's operation is his swap to the bundler from you. Like maybe part of this user operation is at the end of the user operation, I'm actually going to I've signed a pre-signed a transaction to swap USDC for ETH and send it back to this contract, which then compensate calls and like returns to the bundler at the market value at that time, right? And the bundler decided that that was economically viable at the moment that it executed it and was willing to take up that transaction. So like, I bet you it's handled on a meta level, not on a level that is explicit here.
I can, as we've been building with it, so Gelato is one of the people that's trying to do a lot of this. They have a allowed token list, and right now it's wrapped ETH, and that might be it actually.
Really?
So
No way.
and it's just testnet, but like the idea is that, yeah, you're wrapping ERC20, unwrapping ERC20 ETH, native ETH, and obviously there's no risk there, but I think to what Colin's saying, eventually maybe swaps and real shit.
Right. Yeah. Yeah, it's going to be an interesting world, right? Because you're saying like, hey, do this transaction, and then also I execute a market buy for you to like swap my token in a native token to sponsor this transaction back into the native token. So I don't really know how that would look, but there might be there's some samples in here that we can go through, and that might have some examples. There's also this, there's a idea of a paymaster, which I didn't go into. I just went into the entry point and to the base contract stuff. So I think from this point, I think seems like we all sort of understand that there are these user ops, they get picked up by a bundler, whoever that bundler is, they throw them into the entry point contract, which then validates that the user operations can be executed, executes them, and then handles any sort of like refund. Given that, what sounds interesting to people to dive into? We have here the core contracts, so like base account and the entry point, and the paymaster. It requires the paymaster, I believe, has to have a certain amount of stake in the entry point in order to refund transactions. So, yeah, I don't know if people are more interested if we want to look into what like a base account looks like for the wallet abstraction code itself, or do you guys want to look at this entry point contract, or do you guys want to look at figure out like what the heck a paymaster is? But these are kind of like the five things we're working with here.
The token paymaster is in ERC20.
Base paymaster.
Under the samples token paymaster as the example of what?
Oh, there's a token paymaster. Oh, yeah. So okay, cool. Yeah. So here's some of the samples, right? Looks like there's some with Gnosis safes. There's one that does uses BLS signatures instead of ECDSA signatures. There's one that uses, I guess, token callback. I don't know what that is. Yeah, one that uses safe, Gnosis safe. We have a sample account here, and then a token paymaster. So we can look into all of these as well. Probably looking at the implementation, the sample will give us a clue into how the underlying thing works. So yeah, thoughts, guys? What are people wanting to look at? Let's reach consensus here.
Account abstraction would be cool to look at.
Yeah, the actual base account itself.
Yeah.
How does everyone feel about that?
Yeah, start there.
Cool. Yeah, I think that sounds like that would be the meat and potatoes of this. The rest is kind of like infrastructure layer stuff. So I think it would be really interesting to go in a base account as well. And then maybe even like screw around and make our own base account. So, okay, as we go through the base account code, feel free to stop me at any time if something doesn't make sense, or if you're curious about like a Solidity design pattern. This library is super great. The guy who made this is a wizard. He's been working on ETH for like since 2018. He has worked on a bunch of different projects. He's been a software engineer for 30 years. And yeah, he's very, very sharp guy. So you'll see a lot of patterns in here that are nods to other EIPs that are Solidity best practices. So this is going to be like cream of the crop kind of stuff to be implemented at an ERC level. So yeah, feel free to stop and we'll all learn something. Maybe we can start at the interface for accounts first, which is pretty easy. So it looks like there is one function on the account interface called validate user operation. So let's just read this real quick. Validate a user's signature and nonce. The entry point will make the call to the recipient only if this validation returns successfully. Signature failure should be reported by returning a constant. This allows for making a simulation call without a valid signature. So it allows this contract to simulate without failing, right? Because if you asked a contract if a call was valid by actually running it, then the Ethereum transaction would revert, and then you would have to not only would you pay for that transaction execution, but it might be dependent on another transaction and might be dependent on something else. So it's completely delegating to the account itself if a transaction is valid. So it looks like the entry point calls this validate user op, and I believe if we open up the entry point, we saw this validate user op call. Yeah, so in part of validate account, we do a try call to validate user operation. And we say that, validate this user operation with only as much gas as the user is specified in the transaction. And then it passes all the parameters. And then it handles all the try catching and all the errors and the validation itself. So this is some close to the metal code for sure.
Is that, sorry, for the verification gas,
Yeah.
is that something set by the user or the master?
Let's look. Yeah, verification gas limit. So looks like M user op. Oh, so that just means memory. So they've moved the user operation from call data into memory because they're two separate spots in the EVM. So memory is like a volatile byte array. And so you can put anything in it, right? And so it's up to the language to determine how it wants to use that byte array. But call data is a separate space. It's immutable, and it's part of the transaction input. So when a new transaction begins, every transaction that happens on Ethereum, a new instance of the EVM is spun up, like a new frame almost, right? And any cascading call will kind of do that same thing and spin up a fresh frame of the EVM. And part of that frame is the transaction call data, right? So you have access to these things, like tx.origin, message.sender, tx.data, tx.value, or message.data, and then message.value. Those all exist kind of as immutable in each transaction itself. And so, I don't know if that was helpful for anyone, but it just moves the user operation from this call data spot, this immutable position, as part of the Ethereum transaction into memory where the user can mutate it. And so if we go to user operation, part of the definition of user operation is the verification gas limit. So you can imagine why would I want a verification gas limit? I guess let's just pose the question. So first thing that I thought of is that if I had a special account object which needed to check certain parameters on chain, arbitrarily, then someone could create a griefing contract which runs a for loop infinitely. And so when my account checks if a transaction is valid and does a call to the arbitrary contract, it will run a for loop arbitrarily and cause the entire call to fail, essentially griefing that account's user operation, because I can't use that bundle anymore. I can't use that signed piece of data because someone created some sort of like verification flow that that ultimately is unexecutable. I'm sure there's other reasons too, but that was just like first thought, best thought, I guess. Yeah, so back to account, right? So we know that in the entry point, you know, in this for loop, in this for loop, validate prepayment is called, and it checks. And part of that validate prepayment call is the fact that it checks validate the user operation on the wallet, on the account, sorry, not wallet, but account, on the account that actually authorized the operation. How's everyone feeling about that? Cool. Yeah, here this is, I just wanted to make sure, where is this? Validate user op. Yeah, validate user op. Yeah, so the sender, right? The sender is the user operation dot message dot sender. I'm gonna actually pin this user operation so that we have it available here as a definition. So the sender, whoever authorized this call, notice on line 404, it calls that user to ask if this transaction is okay. So it's like a layer of programmability. Sorry about the noise tonight, guys, by the way. It's a little distracting. You're just rolling with it, I guess. Yeah, so must validate it. So this kind of gives us an arbitrary interface for what a wallet that, you know, an EIP4337 wallet has to implement, right? So if we made our own wallet, we did like, you know, contract our cool wallet, we would say it is account, right? And then we would see that our cool wallet should be marked as abstract. And the reason why this is such a crappy error message, I hate this. Maybe if we used, oh yeah, my terminal is broken for some reason. Maybe if we used an npx hard hat compile, we would see that, oh yeah, let me save. If I use npx hard hat compile, I would see actually why. So our cool wallet should be marked as abstract, which is the worst error message ever, but it says note, missing implementation. So it just means that we were supposed to override validate user operation, but we didn't, right? So part of what an I account is that it has this function, and you know, we didn't actually implement it. So if we write our own cool wallet, we would have to override this by taking the function signature, and then we would say, let's see, it's external, so we would call it, you know, external override returns UN256, and then that should be, and then we would, looks like it would return validation data. So it looks like there's a whole schema for, not only is there a schema for user operation, but it looks like there's a schema for validation data as well, which says like there's an authorizer, and there is a valid until timestamp and a valid after timestamp. So it looks like we could say that something is valid, we can say who validated it, and we can say when it's valid until, or when it's valid, or when it will be valid and when it's valid until. So you could only execute it on Tuesday, or you could execute it until, I don't know, 2035, or you could never execute it, right? The user can actually sign on that. So that's super cool.
Yeah, that is really cool.
Yeah.
Can you pause and unpack timestamping?
Yeah, absolutely. Yeah. Let's unpack some timestamping. So yeah, if we notice here that this compiles now, so we get a bunch of warnings because we're not actually doing anything here, but it compiles because I've successfully written an EIP4337 wallet that inherits account. Yeah, what do we want to talk about in terms of timestamp?
In day job as engineer, dealing with time across time zones and formats is a pain in the ass. In a blockchain, you can't just like rely on wall clock.
Yeah.
So the methodology say, hey, do this thing unless it's not until Tuesday, doesn't conceptually make sense on a stateless thing that can't ask the outside world for permission except through oracles.
Correct.
So
So,
like timestamps.
yeah. No, I hear you there. So that's super true. And if you're a developer, you have dealt with timestamps and they make you cry. So if we could write a cool, just like a pure function here. I think free functions cannot be external. So we have this function called getTimestamp, and it returns uint256. So how Ethereum is synced to Unix time. So it's synced to and it's synced to epoch time. So epoch is the amount of seconds since January 1st. Oh my gosh.
70
Yep.
Clearly you're a headphones guy, because that's like not even that distracting to me.
Yeah, I'm absolutely a headphones guy. I'm an AirPods guy. I like AirPods and white noise. I want to hear nothing.
Except the sound of your own thoughts.
Yeah, exactly. But anyway, yeah. So it's the epoch time is the amount of seconds. Is the yeah, right. Is the
That's pretty distracting.
it's pretty distracting.
Even with headphones.
Yeah.
I'm trained to sleep with my eyes open, standing up.
There. What do you do? You should be running this meetup, man. What am I doing here?
I'm literally looking up what a uint is, so no, I should not be running this meetup.
Dude, perfectly valid. So
I didn't want to spend too much time. I just wanted to like, if you had the quick and dirty, how time is handled in a.
yeah, sorry, my brain is just getting pulled a million places. But quick and dirty, Ethereum runs off of epoch time, so it's UTC, right? Universal coordinated time 00, right? And it's the amount of seconds since January 1st, 1970, right? And so here's the current epoch time. We see it like increment in seconds, and there it is. So this value is accessible via like a global in Solidity called block.timestamp. Yeah, so it's available via block.timestamp, right? Some quick caveats to cover about block.timestamp. It is manipulatable by the executor, by the miner, to a certain amount, like around like 30 seconds. They can pull it up or down if they're executing the block. So, it can be basically someone could buy a race condition, is what I'm saying, by like making something execute a little bit earlier than you'd expect. So like use block number if you're writing a program that's dependent on kind of like the current time. You were gonna say, Dave?
Well, so I think what you're saying is it's not actually monotonic across. So second, with the decentralized.
It's like a floating window, yeah.
Yeah, with the decentralized system though, what I'm trying to figure out is if the validators all run this and their clocks are different, how would they possibly agree on the execution?
Well, I mean, I think that's probably solved in the consensus mechanism, right? Because like I would assume that like part of the nodes syncing to one another and the whole like Byzantine generals problem is probably syncing to Unix time, at the very minimum, right? Like if you can't sync about Unix time, you probably can't sync about transactions.
I don't think they actually sync I don't think they're doing like an NTP. What I'm wondering though is maybe whoever's proposing the block puts a time stamp on it, and as long as the validators agree that it's plus or minus the 30 seconds you were saying,
Yeah.
maybe they just accept that and use that time stamp.
Oh yeah, look.
It just has to be strictly higher than the previous block's timestamp.
Yeah. Oh yeah. Exclamation point 3. Right. So I'm sure that's in the yellow paper, the consensus mechanism,
Right.
yellow paper that says like as long as it's larger than the last,
Larger than the last set.
then you're good to go.
So I was gonna say there is no NTP
No.
you can trust in that space. So.
Sure. Yeah.
So
Yeah.
theoretically, if it, like let's say the same validator was getting every single block, could manipulate it to be just 1 millisecond in time faster than this one. I never quite understood.
Or 1 whole second. Yeah.
For a second.
Yeah.
So it would like drift further and further from real, wall clock time.
That's true, but I think if you have, I mean, you would,
Sequential.
but the block number always has to be sequentially
Sure.
incremented, and so that's more trustworthy. I think the fact that like the same block builder would be executing multiple blocks is actually impossible at this point, because of proof of stake. But I don't know how the yellow paper implements proof of stake. That's above my pay grade, but yeah, but I think that's kind of like the TLDR is like do not rely on block.timestamp or block hash as a source of randomness or as a source of like, hey, things can happen up until now because people can kind of like buy their way to do something first. So it's not a fair mechanism, is the point. So yeah, I guess one quick note about block.timestamp. Last quick note. Is if you have a struct, block.timestamp normally is returned as a uint256, which is way too much memory space for what you actually need in a timestamp. Currently, you can use a uint32 timestamp, and so if we do the math here, if we say 2 to the power of 32, that is this large number here, right? 2 Mac. Okay, if we say 2 to the power of 32, and then if I copy this value, and then maybe say drop it into a date object, because I'm actually still a script kid at heart, right? So if we date object takes in milliseconds. So here's the amount of seconds, right? So you could say that the amount of seconds that from now to, or from 1970 to however long the space it takes to fill up an entire uint32, it would take you to the year 2106, right? So that's like, plenty of time to have a cool failed blockchain startup that only lasts 3 years. But if you're trying to like theoretically future-proof your timestamps, then you can use a uint40. And so if you use uint40, if we go 2 to the power of 40, you could say that if your program relies on like on timestamps that last until if your program has like a domain definition for what a timestamp is, and that's hard typed to uint40, that could take you to the year 36,000, right? So just like a quick note on typing is that like if you used a uint256, that would take up an entire slot, and you would just have you'd be paying for a lot of wasted zeros. But if you use a uint40, you're safe. And I bet you if we search for validation data, struct validation data. Yeah. So they even use a uint48. So there's plenty of time here. And the reason they're using this is because like they have this address here, which is a uint160, and then a uint48, and then a uint48 that fills an entire slot. So that's 256, which is 32 bytes, which will be one slot in storage, which means you're paying to write one time. Versus if these were both 256s, you would have your users paying to write 3 storage units in Ethereum, which would be 3 times as expensive. So yeah. Sorry, that was a little long-winded.
No,
Okay, cool, good. Any other thoughts on timestamps or?
Well, it is cool, but I've been in a situation before where, like, writing scripts to execute a bunch of Ethereum transactions where broadcast failed on some of them, and then like the nonce would get like messed up, and
Yes.
just keep on going or whatever. And then actually you could kind of replay attack that if you knew like exactly what the transactions were, because maybe now you don't want to execute like all those not exactly a replay attack, but like you could do a transaction that did like the nonce that was missing, and then all the other ones would execute afterwards, and you don't really want them to. So like in a case like that, having the hey, only run this in the next 15 minutes is a nice feature to have.
Yeah, it's pretty cool. Like one thing that's definitely underutilized, especially by wallets, is that like part of the 2612 permit signatures, which allows you to, those annoying ERC20 approved transactions that you have to do normally. They're annoying, but they're really important. They're bad UX, but great UX at the same time because you still have all your money. But that's kind of been replaced. If you've ever done a signature, like a gasless signature to approve spend, that has a timestamp in it. So it's I forget what the name is, but you'll see it in there as a timestamp. And like literally, unless you're a dev and you know the spec, you copy it into your console and like create a new data object, right? Like it's theoretically though, it's a way for you to specify the maximum amount of time for your token approval, which I think is cool, right? You're like, hey, I approve this dApp to use 1,000 tokens, but only for the next 5 minutes, right? It's like versus the whole infinite approval thing. I really like narrowing the scope of approval, and I think it'll make things a lot safer anyway.
So, just looking up, EIP4337 is currently marked as stagnant, but it's the EIP to define a maximum block timestamp drift.
Oh.
So, like what you were describing with the 30 seconds or whatever.
Yeah.
But apparently it's marked as stagnant. And here, the actual proposal I think is for 15 seconds either way.
15.
Yeah.
Okay. Yeah, I like that. I mean, that makes sense because the block, each block, it's about 15 seconds. Now at proof of stake, it's like kind of locked in at about 15.
The other thing that I was reading about here is it says from another paper that the actual time itself is the output of Unix's time function, system time.
Oh, cool.
And
Unix system time. Nice.
Right, which is nice with the exception that, today, Unix system time is a 32-bit integer, a signed integer, not unsigned.
Oh.
So that means
to the 31.
2036 or 2037.
So if we
before that blows up, but I'm sure they'll update it at some point to be.
Yeah. So no, that's
else,
actually a
but-
great like computer science note. We'll talk about that, right? So like 32 byte. So like a uint32 is it gives you 32 bytes of number space to do stuff, right?
But you only have half of that because it's signed.
No. You have one less. You have one less
Or you
byte.
not half.
Yeah, so you when you say that something's an int32, instead of having 32 bytes of space, 32 bits of space, apologies,
Yes.
big difference. Instead of having 32 bits of space, you have 31 bits of space
Yep.
because the first bit is used to determine the sign. So if it's a 1, it's negative. If it's a 0, it's positive, right? So like if they're using signed integers to do Unix time, this is our new number because now we only have, so we kind of have like one less exponential increase. So yeah, oh yeah, that's the 2038 problem.
Yes.
So if it's a signed 32 bit int, then it'll only take you to uint. Well, it'll only take you to January 18th, 2038.
38. But to the extent that Ethereum is prepared for a larger amount of time, at some point if Unix systems update to a 64-bit or something else,
Mhm.
then it looks like Ethereum would just handle it gracefully.
Yeah.
So
Right. Yeah. No, true. Yeah, I mean, and Ethereum's built for that, right? Like there are bigger problems like we'll have to do post-quantum signature verification before we'll have to do, uint 31 timestamps. But like this is the Y2K problem, right? So like when a 31 signed integer overflows, it will just add, it'll add 1 bit anyway, so it'll be interpreted as a minus. So meaning that everything will flip to December 13th, 1901. If you don't update. So maybe you'll find some fun legacy systems on, January 18th, 2038 that now read 1901, and you'll go back in time for a day and giggle about it. Think about this meetup. Yeah, right? True. Maybe that's what it was about all along. No, but good lore there. Okay, cool. So here, I think we kind of naively inherited off of iAccount. Usually, we would inherit off of base account. So this is the basic account implementation. It provides the basic logic for implementing the iAccount interface, which has the validate user op function that we're looking at. The specific account implementation should inherit from it and provide account-specific logic. So here's that constant that we were talking about. So this is an abstract constant, right? So like any contract that we would write inherits off of this. With this abstract like key here, it allows us to do like weird things like define function signatures without implementing them, right? So this is a virtual function and there's no implementation, which means the inheriting contract is forced to write its own implementation. Same with entry point, which just returns the address of the entry point. This validate user operation. This is like, I guess, yes, this is an external override, but it's also overridable itself because it uses that virtual keyword. So this, in the simple case, validates the user's signature and nonce. The subclass doesn't need to override this method. Instead, it should override the specific internal verification methods. So it looks like it should leave this method as is, but override the require from entry point, validate signature, and pay prefund functions probably. So this is probably, let's just step through these real quick. This is a short file. So yeah, it requires from entry point, which means that like this is an internal function used in the validate user op to say that only the entry point can validate a user operation, right? The message sender equals the entry point. I'm sorry, went a bit fast there. The validate signature scheme. This returns the validation data, which is encoded as we see here in the return data. We're supposed to override these validate and update nonce. Oh yeah, here. So let me split this out. It told us to override these internal functions and not to override this. And here we're seeing these virtual stubs for all these functions that we're supposed to override ourselves, right? Validate and update nonce, pay prefund. let's see, sends to the entry point the missing funds for this transaction. So the subclass may override this function for better funds management if it wants to do something custom, but it doesn't have to, looks like. So there are a few things that we're seeing here. We're seeing kind of like these stubs that the contract wants us to inherit off of, or sorry, write our own implementation for whenever we inherit. So I think probably the next best move is going to be going into a quick base account or a simple account sample. So we see how kind of everything is finally combined together and we can kind of make a 4337 wallet. But any thoughts or musings before we jump forward? Cool. Looks like this is using the user operation lib for user operation, which that might be interesting to take a look at. I'm sure there's ways given a user operation to extract certain types of data in here, get the gas price. Looks like pack and unpack. So, you know, how you kind of convert and manipulate this data to take a user operation and cast it down to a byte string, how to hash it. So just some like, oh yeah, this is in the user operation file that we already had pinned. So nice. Cool. All right, let's look at a simple account. So samples, simple account. All right. So looks like a simple account inherits base account. Interestingly, it inherits a token callback handler, and it's also upgradable as well, which is interesting. So it says that this is a minimal account, and it's a minimal sample account. So it's just like a sample implementation. It's not part of the EIP. It has execute and ETH handling methods, and it has a single signer that can send requests through the entry point. So like, you know, if my wallet was abstracted, this simple account would be, it would represent my wallet. So looks like it stores the nonce and the owner, right? So in the same way, we're kind of getting the exact same definition that we have in normal like Ethereum. Maybe it's on my Brave browser. I think I have the Ethereum handbook somewhere here, but this is like the Ethereum handbook is really interesting to look over. And Ethereum handbook Notion. Where is this? I put it somewhere in EVM handbook. There it is. Here it is. But there's some really, really solid kind of deep dives into how Ethereum works, and part of the EVM illustrated, which is really nice. Part of this is like how like what is actually stored in different types of accounts. Yeah, this is somewhere in here. So an account. Yep. So here's an account, right? Every Ethereum address now, every EOA has a nonce and a balance, and then smart contract accounts have like storage hashes and code hashes, which we're talking about storage hashes for storage proofs. But yeah, so we're kind of seeing this exact same thing happen. Is we're having like the owner, which is like kind of the address the address itself, and then we're also seeing the nonce here as well. So it kind of has its own ways to manage its own nonce. It's also storing the entry point address, which is the address that's allowed to call it. So it has a public view function for the nonce to see like what the nonce of an account is, which is pretty sweet. Currently like one limitation with Solidity, and I think maybe the EVM in general, is I don't think there's, with the EVM in general, there's no way to get the nonce of an account. So I couldn't say like address, I couldn't say like, you know, message sender, like what's the nonce of this account? Like it doesn't exist as a member on address, and there's no way to call on chain. There's no way to read an account's nonce. You have to do it off chain. And so this is nice because that's like a big improvement, is you could actually read the nonce of an account. So you could say like, you know, you could do like an airdrop, or, you know, some sort of verification for people who have done over 1,000 transactions, right? Because like their nonce is incremented. That wouldn't really be secure, but that's neither here nor there. This is interesting. This is a receive function. So this allows the smart contract to receive Ether. So we talked about this. We've talked about this, I think, in length at some other meetups that we've done here. But there's a receive and a fallback function. Every time you create a new transaction to send Ether from one account to another, the receiving account will be invoked. And so if the receiving account is a smart contract account and it doesn't have code to handle that invocation, with Solidity, it'll revert by default. So this is a signal in the Solidity contract that says, hey, this contract is allowed to just like arbitrarily receive Ether, and since this block is empty, it's just a no op, so it does nothing. You could do something crazy, like you could you could emit an event, right? You could emit an event that like says how much you got paid. You could do whatever you want in here, because in receiving Ether, you receive the function execution, and you can do whatever you want. But in this case, it just handles the Ether and then passes back the function execution to the callee. This is a constructor, so this handles kind of the initialization of the contract. There looks like kind of like a only owner modifier, right? It looks like it has a function for execution. So you execute from either the entry point or the owner, which means that I could hold this smart contract account. So like imagine this simple account is like a Gnosis safe, right? Whereas like I have my own MetaMask wallet here, right? And this is my EOA. But then I could also create like a Gnosis safe and do other stuff with it. This is going to be the same thing. So it's like kind of like a smart contract account that exists external for my EOA. I could do things on here anyway, as long as I'm the owner, but I could also do things in a way that's gas abstracted if I'm the entry point. So yeah, and what this execute does is it calls this internal call function, which just calls the target with the call data and the call value, and returns success if it was successful. Otherwise, it will revert. So like this, we're starting to see like some repeating patterns here from the Gnosis logic, because kind of like smart contract wallets are all pretty similar to each other for the most part. This is pretty cool. This has execute batch, right? So like since I can do arbitrary things on this smart contract account, I could also like execute batch transactions. So I can finally bundle my token approvals and whatever I want to do into one transaction called execute batch, which could be sponsored from an entry point. So like this kind of, we start to see how this is solved, right? How we solve these Web3 UX problems. And we solve each problem by writing these custom accounts. So, you know, if you wanted to write a social wallet, then you would write your own sample account, which inherits off of base contract, right? And you can do whatever you want in that contract, but part of it is you kind of create this like, you follow the EIP logic for what an entry point can and can't do. In the same way, when you want to make your own token, you use the ERC20 spec to say, hey, here's what you call when you want to say balance of, here's what you do when you want to say transfer from. It's all kind of the same. It gives you like a rough interface, but then you can tweak the inner workings behind the scenes. So I think that is all pretty, this is the initializer function. yeah, this requires that the entry point is the message sender or the owner. This will handle how you validate and update that nonce. So notice how it asked us to override that stuff in the base account. So if I crack open, yeah. So if I crack open base account on the right-hand side and go back to this validate user op, one, it wanted us to override require from entry point, which we have done, not done. Oh, that's already written here. It wants us to, yep, override validate signature. So validate signature, that's what we wrote, and it'll, and then it also wants us to implement this. So if we say validate, let's look at this validate signature implementation. So when the entry point calls validate user op with all the user data, what this does is it takes in the user operation data and the user operation hash, which is just like the kind of the unique identifier for whatever user operation I want to do. What it's going to do is it's going to use EC recover, which is the elliptic curve recover. Basically, it just checks, hey, given a signature and a hash, who signed this? And so that this recover call will return an owner. So it returns address, right? And it will, this is using Open Zeppelin's library, but like you could do, the built-in for Solidity is called EC recover. And you would also have to split this signature into a V, an R, and an S. So you take the hash and the R, the S, and the V, because it's backwards in this case. And this is like what's called a precompile contract. And it just runs the elliptic curve, the ECDSA signature recovery, and it will spit out an address. So it says, hey, this address signed this hash. And that's exactly what the node does as well. So it takes, when I do my transaction normally now, it just hashes the data down, signs it, and then checks that the user is the sender and that the user has enough balance, and then puts it on the chain. So it looks like this is just kind of like a really simple one-for-one replacement of kind of like my normal EOA, externally owned account wallet. It's doing just the same EC elliptic curve signature verification. And looks like it returns 0 if it was successful and returns 1 if it was failed, which that really bugs me because that's not how you program. But yeah.
You're writing C Unix programs.
Yeah.
That's exactly how it was.
Oh, seriously? It's the reverse that way?
Yeah.
Yeah, 1 is on, dude. 0 is off.
Finished clean.
What the-
Even on your Mac, if you run something on the command line, if you type echo $?
Yeah.
If it's a 0, it ran successful. If it's any other number, it represents.
Oh, you're
the
right.
code.
No, even in Node, yeah, process exit 1 is fail,
Yeah.
and process exit 0 is success. That's, yeah, you're right. Dang. There it is. But yeah, I know we just hit time. Yeah, that looks like I guess like a pretty brief overview of like an implementation. It allows you to, I guess maybe just to recap, right? Alternate mempool for these cool user operations, which can be bundled by anyone and sponsored. It returns a, I guess it defines a standard for like what an entry point is, which is just kind of like this executor, right? The executor, and then it also defines the interface for an account, which allows the executor to check if a transaction is valid before it actually goes and executes it on behalf of that account. You can write whatever you want in the account. And I think really this is the powerful function here, is the very last one, right? Is, validate signature. Is like, you could write anything you want in here. If the user has enough money, if there's enough, if there's enough multi-sig verification as part of the signature, if, like it just, the list goes on and on, right? You could do you could pass whatever data you want in the user op, and you could pass however long a signature you want in the op. So you could write a signature on your own curve. You could write a ZK signature. You could verify your signature against another function. You could say this wallet can only execute if USDC depegs, right? Like you can check any on-chain parameters. You could check the time. You could do so many cool stuff with this, and it all kind of resides in this validate signature function. Kind of like I think the world is your oyster, and this is where you wanna handle all the cool custom wallet stuff that you could ever want to do. So yeah, cool thoughts, final notes.
No, I'm excited because I've been like in the user experience space since like the Bitcoin days. So work on like the early wallets.
Yeah, well,
which was a thing, and
right.
that continues to be the case. Is like
Yes.
the UX is so hard.
So hard.
And even like he was mentioning, we did like the whole beta with the options platform.
Mm-hmm.
Part of what gets me excited is like, hey, really make these things accessible and
Right.
put in a lot of work to make things easy.
Yes.
There is only so much that you can do.
Right.
And ultimately it does come down to, okay, I am a new user and I'm trying to like do this, and you say, well, you have to kind of go through all these things.
I know.
Because wallet is kind of like your entry point.
Yeah, it is. Yeah, it is, right? You see that like connect with MetaMask page, and you're like, one, why would you name a piece of software MetaMask? And two, why do I need it? Can I just like poke around your app? And it's like, no, sorry, like we need it for the provider, and we need you to sign messages, right? It's like we're still developing apps for ourselves, you know?
Yeah, and then a private key. Don't share it with anyone. Oh, let me take a screenshot.
Yeah,
Oh, no,
right.
I forgot.
Yeah, exactly. Yeah, let me put
But
it.
I also put money in there.
Yeah, let me put in my iCloud backup. I know. It's yeah, I like love this idea of progressive decentralization where like I mean, we trust every day, right, for you to be that like Plaid is secure enough for you to like pull in financial data and like execute transactions in my bank account, right? PayPal authentication is secure enough, right? Like we trust these things every day in Web 2 to get people onboarded. And so like I think it's powerful enough to say that we can keep trusting those layers for now, but like it's like we lower the barrier to entry, but we still allow you to like if you came on your options platform and I like authenticated with my bank account, right? In the background, once that authentication happens on your back end, you create a wallet, an account abstracted wallet. You front the gas for that transaction. The user just waits 10 seconds while their account is being created, and then they do things with like normal buttons that they click. But like if they're ever in their settings menu and they want to try on blockchain for real, they hit the eject account button, and then they just get all their they get their user migrated. They get their keys basically, right? And so they've taken custody on like their blockchain journey, but you started them by like the things that they know and trust.
So I've been testing, and this is all like really exciting, awesome stuff for all those reasons, but it's also going to be like a massive challenge. Like,
Yeah.
I've learned like hopefully good habits, but like as you like, it's so weird now clicking a button and not getting a second pop-up and giving myself a second chance to be like, okay, what's gas, what's
Right.
all this stuff, like, because
Yeah.
using like a social login, sponsored wallet, we're just proof of concept.
Yeah.
But like hitting a button and then not really seeing or like having a better understanding of what's gonna happen is like actually like jarring for me. For other people, like it's like I don't want to know. But
Right.
It
Right.
is weird.
It is. Yeah, you leave the world of. Yeah, when I see MetaMask, I think I'm like that the older lady with the calculus floating around her head. I'm like that meme. I'm like, do I here the.
No, I'm sketched out every time I'm using MetaMask. Like I keep it.
This is me. I'm like thinking. I'm like, do I really want to sign this transaction? Is this?
But part of that that paranoia is good, right? Like you should want.
But see, I think, so that's kind of like the thing, right? Like, I think all of us, like, when we operate at a paranoid level, like, at least for me, it was a complete change, because I came
Yeah.
from a, completely front-end world, and
Right.
then my first company was like, oh, I don't, people are like, I'm off the grid,
Yeah.
sort of, but it really, it's like, you're like, oh, you have to do that,
Right.
otherwise, within seconds, life changes for you.
Yeah, no, it's like 1997 again, right? It's
But
like
then I think
a new version of the internet.
UX side is so hard, because you still talk to an average user,
Yeah.
and when I first joined my first company, like, somebody would be like, oh, I have 20 BTC in this wallet, and I don't know where my keys are.
Wow. Yeah. that's
But I have a password. Can you send me a reset password link? They were like, no, there's no
no.
reset password.
Oh man, that's heartbreaking.
So, and I think that hasn't changed since 17.
Yeah, no, it really hasn't.
Because last year we did NFT. So we did an NFT series last year, and it was interesting to see, like, the question level people have, because what's happening is more and more people are actually onboarding into crypto, and it continues to be hard to talk to a new person. Like, people weren't even able to buy crypto on our platform. It's very hard. Like, the UX side is hard, and
Yeah.
Unfortunately the new users don't care about security. They don't care about.
Right.
They like to press the button.
It's fun to press the button. Yeah, no, true. Very
See,
true.
I feel like it should be such that you are still pressing the buttons, but the code side is just kind of, watching out for you and taking care of you. Like,
Mm-hmm.
you don't have to know all the technicals. You don't have to understand all the.
Yeah, you shouldn't, right? Yeah, I mean, if it's ever going to reach adoption, you shouldn't have to.
Right.
No, but well, cool. Thanks, guys, for coming. We're probably gonna.
That question on the stream.
Oh wait, there's a question on the stream. Does it have to be a signature? Can it be a zero knowledge proof and arbitrary function? During my hackathon, we try to get biometric to work with account abstraction. Yeah, I mean, so like that's the cool thing, right? Is if you return 1 from this, if you return 0, if you return 0 from this function, your thing executes. So you can do whatever you want in there. That's pretty cool. What's up, Paul?
Hey.
How's it going, man? But yeah, thanks for coming. If you guys want to stick around and like mess around with more Solidity stuff, I'll probably be chilling here for another like 10-15 minutes. We can keep jamming. But if you got to go, want to respect the time.
We
So.
also have 2 pieces of pizza left.
Ooh.
It's gotta go home with somebody.
Also, yeah, Brent, shout out. Thanks for coming, man, and chilling in the stream for like an hour and a half. Execute Batch is lit, and we hope to see you in person one of these days. We know you're far away, so. All right, gang.